Virtual network peering is a way to enable communication between two or more virtual networks in Azure. Here is our first question. So it says you have an Azure subscription that contains 4 virtual networks named VNet 1, 2, 3, and 4. Now you plan to deploy a hub and spoke topology by using virtual network peering. Good enough? You need to configure VNet 1 as hub network, and the solution must meet the following requirements. It should support transitive routing between spokes and maximize network throughput. So what should you include in the solution? This is a long question, so understand it. You have the hybrid network shown in the network diagram exhibit. It says on-premises network we have, then on-premises network is connected by using site-to-site VPN and Azure Virtual Network and Virtual Network 2 and Virtual Network 3. Hello everyone, welcome to this video of 591 Lab. I am Manny and I'm thrilled to have you here. In this video, we are going to learn about virtual network peering, hub and spoke topology, and virtual network gateway. After that, we will review Az-700 exam questions and understand them in detail. Whether you are preparing for Az-700 exam or you are working as a cloud or system admin, this video provides an insight in the world of Azure networking. Before we begin, here we have our humble request to subscribe our channel, like the video and hit the notification bell. This helps us to create more content like this to help you to excel in your cloud journey. Let us introduce ourselves first. We are 591 Lab and we are the top IT training and certification exam brand in China, Hong Kong, Taiwan, and Singapore. Our mission here is to provide our clients with exceptional exam preparations experience for certifications in Cisco, Huawei, Aruba, Juniper, Microsoft, and Azure Cloud. To know about us in detail, please visit 591lab.com and subscribe this channel. Without spending any more time, let's start our learning. Here is our agenda for this session. We will start by understanding the concept of virtual network peering, and we'll see how to set it up. Then we will talk about virtual network gateway and its uses, and later we will discuss hub and spoke topology. At last, we will review Az-700 exam preparations questions and understand them in details. So let's go. Virtual network peering is a way to enable communication between two or more virtual networks in Azure. By definition, it is quite simple. So let's understand this how it works. Let's say in Azure, we have one virtual network. Inside that, we have 2 subnets, and each subnet has one virtual machine deployed as resources. So the architecture looks like this. We have one virtual network, 2 subnets, and one virtual machine in each subnet. We need to remember, by default, connection between the resources of different subnets within one virtual network are allowed. Subnet 1 and Subnet 2 inside VNet 1 are allowed to communicate. No separate configuration is required. So VM1 can communicate with VM2 easily and without setting up any specific network between them. Now let's add another virtual network with the same setup. Here we have VNet 2. Inside that we have Subnet 1 and Subnet 2 with VM3 and VM4 respectively. So here's the question. Can VM3 or VM4 communicate with VM1 or VM2? By looking at this diagram, the answer is no. And why is that? Because connection between 2 or more virtual networks are not allowed by default. This means when we create virtual networks and multiple or 2 virtual networks, then the default communication is not allowed between them. Now the resources in 2 different virtual networks cannot communicate with each other. So VM3 cannot communicate with VM1 and 2. Similarly, VM1 cannot communicate to VM3 or 4. To enable the communication between them, we need to configure virtual network peering, or in short, VNet peering. Once the peering is in place, VM1 would be able to communicate VM3 or VM4 and vice versa. Similarly, VM2 is also able to communicate with VM3 and VM4 and vice versa. So here, in order to communicate between VM2 and VM4 and 3, we need to enable VNet peering. So after enabling the VNet peering, all the resources across these two virtual networks are able to communicate with each other. Now let's go to Azure portal and where we have a similar setup, and we will learn how to configure virtual network peering. So we are in our Azure portal. First, we will check the virtual networks. Inside this, we can see we have two virtual networks, Virtual Network 1 and Virtual Network 2. Inside Virtual Network 1, if I look into the subnets, I can see I have created the subnet 1 and subnet 2. Similarly, I need to check in Virtual Network 2 and I have subnet 1 and subnet 2. So for Virtual Network 1, I have two subnets, and Virtual Network 2 also I have two subnets. Now if I go back to the virtual machines, I can see I have deployed 3 virtual machines. If I click on the virtual machine 1, and I can see to which virtual network and subnet it is deployed, so I can see virtual machine 1 is a part of Virtual Network 1 and subnet 1. If I look at the virtual machine 2, then it is a part of Virtual Network 1 and subnet 2. It means VM1 and VM2 are in different subnets, but both of them are in same virtual network. So by default, communication between VM1 and VM2 should be allowed. For that purpose, let's go and log into those machines and verify the communication. So I have logged into that machine and I'm just going to check. So this is my VM2. Just to verify which VM is this, I'm opening the command prompt and type host name. So this is showing this is my VM2. Also check the IP config, which is giving the IP address 10.0.2.4, and this is the private IP address of my VM2. Let's verify in the portal. 10.0.2.4 is the private IP address of my VM2. Now go back to VM1 and 10.0.1.4 is the private IP address of VM1. So if I ping from VM2 to VM1, it should be able to communicate. Let's see. We can see here, we are getting the response from the VM1. Now let's go to the VM1 and see if we are getting the same response for VM2 or not. So I'm in the VM1, open command prompt, type hostname just to verify if we are in VM1, and then type ipconfig to get to know the IP address of this VM1. Now we need to ping 10.0.2.4, which is the IP of VM2, and we'll see if it is connected or communicated or not. So now we can see we got the response from VM2 as well. So VM1 and VM2 are able to communicate with each other. Now look at the VM3. In this portal, the IP address of the VM3 is 10.1.1.4. Let's go and ping this IP from VM1 or VM2. So I'm into VM2. Let me make it large. Okay, so I'm VM2 and I'm going to ping VM3, which is 10.1.1.4. And I can see no response. Let's check in the VM1 as well. Ping 10.1.1.4, which is the IP address of VM3, and see if we get any response. Check again in the VM2. So you see here, we are getting the response request timeout, which means VM2 is not able to communicate to VM3. Let's see if we get the same output in VM1. In the VM1 also, we get the same output. So now we understand VM1 and VM2 are a part of different subnets, but one virtual network, and that is why they are able to communicate with each other. But VM3 is a part of different virtual network, and that is why it is not able to communicate. So let's refer back to the PPT one more time. So VM1 and VM2 are able to communicate with each other. However, VM3 is not able to communicate with VM1 and VM2. In order to do the communication, we need to enable the VNet peering. So let's go and enable the VNet peering and test the communication after that. I'm in portal again, going to home, and then I'm going to the virtual network. So what I need to do, I need to communicate VNet 1 and VNet 2 by option of peering. So let's open the VNet 1. Here we have peerings. In the left side panel, we can see the peerings. You can see there is no peering available here. So let's go and add one. Now, here we have a small web page where we need to fill some information. So let's understand one by one. Here, this virtual network means since I have opened this page from the VNet 1, so this virtual network is going to refer VNet 1. Now it is at the bottom, it says to which virtual network I'm going to connect the peering. So I'm just going to choose VNet 2 here. So once you choose the VNet 2, you can see few options have been changed. If I'm just going to here, you can see allow VNet 1 to access VNet 2. Before that, I need to give a name. So I am mentioning VNet 1 to VNet 2. So VNet 1 hyphen VNet 2 means I am doing a peering from VNet 1 to VNet 2. Now I have few options to check. Allow VNet 1 to access VNet 2. Yes, we would like to do that. Then second option says allow VNet 1 to receive forwarded traffic from VNet 2. So it means if I go back to the PPT again, so it is saying like allow VNet 2 to receive, allow VNet 1 to receive traffic from the VNet 2. And it means any traffic which is going to send from VNet 2 to VNet 1, it should be allowed. So coming back to the portal, and I need to put a check mark here. Now again, I need to provide the peering link name for the remote virtual network. So here I'm just going to do VNet 2 to VNet 1. And again, I have to choose the option. I mean, this is the option which is chosen by default. Let's choose the another option which says allow VNet 2 to receive forward traffic from VNet 1. Yes, we would like to do that also. Now there are two more options, allow gateway and enable VNet 2 to use remote gateway. These two options we will discuss later in this session when we will first talk about the virtual network gateway. As of now, keep them unchecked or black. Hit add and see if it is getting created or not. So now you can see the moment I hit add, I can get the notification here, added virtual network peering, successfully added virtual network peering VNet 2, VNet 1 and VNet 2. So let's go and confirm. We are in VNet 1 and in the peering, I can see VNet 1 to VNet 2 is connected. Similarly, if I go to VNet 2, I can see VNet 2 to VNet 1 is connected. So here VNet 1 and VNet 2 are now connected with each other by the option of network peering. So once again going back to the PPT for the reference. So VNet 1 and VNet 2 are communicated with each other with the help of VNet peering. Now let's see if VM1 is able to communicate to VM3 or VM2. Let's go to the VMs one by one. So I need to confirmation in which VM I am. I am in VM1. So let's ping 10.1.1.4, which is the IP address of VM3. And now you can see I am getting response from the VM3. You can see earlier when we ping that VM3, we were getting request timeout. Let's do the same for VM2. Okay, we are in VM1 again. Sorry. Now we are in VM2. So check again the hostname VM2 ping 10.1.1.4 and see we are getting the response or not. So here is our response, which means VM2 is also able to communicate to VM3. Now it's time to go and log in into the VM3 and see if VM3 is able to communicate to VM1 or VM2. So open the command prompt, type hostname to validate the VM name, which is VM3, ping 10.0.1.4, which is the IP address of my VM1. And I think if change it to 10.0.1. Okay. I need to check the IP address of my VM2. I mean the private IP address coming here and VM2. So, okay, it's 10.0.2.4. So, sorry about that. So, it's ping 10.0.2.4. And you can see I'm getting the response from VM2 also. So VM3 is also able to communicate to VM2. Coming back to my PPT. Till now, we have seen how to enable VNet peering between VNet 1 and VNet 2. We have also seen how communication is happening from VM1 or VM2 to VM3 and from VM3 to VM1 or VM2, which means after enabling the VNet peering, the resources within these two different virtual networks are able to communicate with each other. So now we understand the concept of VNet peering. Let's go and have a look at some key points about virtual network peering. Connection between resources of two different subnets within one virtual network are allowed by default. We have seen this. VM1 and VM2 are able to communicate with each other without any specific network configuration because they are a part of different subnets but one virtual network. However, when you look at the second point, the connection between two or more virtual networks are not allowed by default. So by default, virtual networks are not able to communicate with each other. We have to do the network peering or VNet peering to allow the communication between them. The traffic between resources in peered virtual networks uses the Microsoft backbone infrastructure, which means all the communication happening across all the resources in different virtual networks after enabling virtual network peering is going to happen by using the Microsoft backbone infrastructure. And no downtime to resources in either virtual network when creating the peering or after peering is created, which means VM1, VM2, VM3 or whatever the number of VMs or resources we have. No downtime is required when we are creating the virtual network peering or even the peering is created. So resource downtime is not required while working on the virtual network peering. The next point says VNet peering is non-transitive in nature. This is a very critical and important point to understand. What is non-transitive in nature? So let's assume we have VNet 1, VNet 2 and VNet 3. We also have VNet peering set up between VNet 1 and VNet 2 and VNet 2 and VNet 3. So VM1 can communicate with VM2 and VM2 can communicate with VM3. So VNet 1 and VNet 2 has the peering and VNet 2 and VNet 3 also has the peering. But this does not mean the peering is going to work for VM1 and VM3 because there is no direct virtual network peering between VNet 1 and VNet 3. So whenever this kind of situation occurs, we have to remember VNet peering is a non-transitive in nature. It does not mean if VNet 1 is communicated to VNet 2 and VNet 2 is communicated to VNet 3 by network peering, then VNet 1 is also going to be communicated with VNet 3. This is a key point to remember. That's all about virtual network peering. I hope this explanation about virtual network was clear to you. Now it is time to move to next section, which is Virtual Network Gateway or VPN Gateway. Virtual Network Gateway is used to send encrypted traffic between an Azure virtual network and on-premise locations over the public internet. This is also used to send encrypted traffic between Azure Virtual Network over the Microsoft network. Now, as the name says, Virtual Network Gateway is a gateway at virtual network, which means this is the point from where the traffic goes out and comes in to the virtual network. It is used in two scenarios: to connect Azure Virtual Network to the outside world like on-prem infra or other cloud providers, to enable the transitive communication between multiple virtual networks by using hub and spoke topology. Now let's look at the diagram. Here is the diagram. In this diagram, Virtual Network Gateway is deployed in one virtual network under the dedicated subnet called Gateway Subnet. You can see here. So this Gateway Subnet is a special subnet which is only used to deploy Virtual Network Gateway. Once we deploy the Virtual Network Gateway inside VNet 1 or any other virtual network, we can configure site-to-site or express route VPN to communicate or establish communication with outside world on-prem or the other cloud providers. This communication happens over public internet by using the encrypted traffic. Now, setting up the communication with on-prem infra is a separate topic to discuss, which we will learn in another session. For this session, our focus is to learn the second use of gateway, which is to enable transitive communication between multiple virtual networks by using hub and spoke topology. Before we learn this use of hub and spoke topology, let's go to Azure portal and create one virtual network gateway and see how to set it up. After that, we will see the use of this virtual network gateway to setting up hub and spoke topology. So let's go to Azure portal. We are in our Azure portal again. Now, before deploying virtual network gateway, we need to recall the last PPT, which is this one. So we can see here, to deploy virtual network gateway, we need to have one virtual network and then a special subnet, which is called gateway subnet. So let's go to the portal again, create a virtual network and a gateway subnet. Here we are. To create a virtual network, first we need to search for the virtual network here. Hit on create. It will load a page and we need to fill some information. So we are going to use this resource group and the subscription, and let's call it Hub VNet. This is the name of our virtual network. So I'm calling it a Hub VNet. Hit on next. We'll keep these options as it is. Now we are going to use this address space, which is 10.0.0/16. Now coming back to this subnet section, and here we are just going to mention subnet 1, which is our subnet, the new subnet, which is subnet 1. Click on save. Now you can see the option here to add a subnet. Click on this, it will open this page, and here once you will expand this, you can see here we have subnet purpose. So let's say you can see here the virtual network gateway. Select this and you see the name shows gateway subnet. So this is a defined and dedicated name of further gateway subnet. You cannot change it. Even if I want to change it, I cannot change it. So I need to select virtual network gateway from this box and then it will automatically populate. Now I simply need to provide the address for the subnet. So I'm choosing this 10.0.0/27, which is I'm going to get 32 address, which is absolutely fine with me. I'm just going to hit on add. So now I have my virtual network and then subnet 1 and a gateway subnet. Hit on next, next. And it will run the validation and then hit on create. Now our virtual network is created. So go to home and see. Here is our virtual network. Click on here and then go to subnets. We have our gateway subnet and we have our subnet 1 also. Now let's go to home again and search for virtual gateway or virtual network gateways. You can see here this option. Now let's hit on create button. And we have a web page come where we need to fill some information. So first thing talks about the subscription, which is our subscription. The second column says resource group. And now look at this information. Select a virtual network to get a resource group, which means the moment I'm going to say like this in this virtual network, I am going to deploy my virtual network gateway. It will automatically picks up the resource group name. So let's look at the option where I need to select the virtual network. This is the option. So click here and select HubNet. So HubNet is a virtual network where I'm deploying my virtual network gateway. Now it is asking me to provide the name for the gateway. So I can call it like gateway 1 or GW1. So the region will be East US. Gateway type, let's as of now keep it VPN, and we can change the gateway SKU as well. So let's keep all this information as it is. Now, whenever we create any virtual network gateway, we need to create our public IP address as well. So we have not created any public IP address. So let's create new one. However, if you have any existing public IP address, you can choose this option. For us, it is gateway 1 PIP. Let's keep all these options as it is. We are not configuring any kind of BGP, and we do not need any secondary public IP address. So we are just going to keep it disabled. Now this is the basic form which you need to fill and hit on next. If you have any tag, please hit on tag, then click review and create. Now the validation is passed, and now hit on create. So it is submitting the deployment and it will start the deployment. Virtual network deployment is a lengthy process and it is going to take somewhere around 45 to 55 minutes. It depends on the bandwidth and the availability at the Microsoft data center. So as of now, I'm just pausing the video and will resume once the virtual network gateway is created. So after waiting for somewhere around 45 minutes, the deployment of virtual network gateway is completed. Let's go to home and verify. Search for the virtual network gateway. And here we can see the gateway 1 is deployed. Click on it and we'll see the gateway is deployed. So after this, it is time to go back to our slide. This is our slide. So we have deployed virtual network gateway and we have seen how we have used hub VNet, and inside that we created gateway subnet and deployed virtual network gateway. This is all about virtual network gateway. Now it is time to learn hub and spoke topology. For that, let's move to the next slide. So hub and spoke topology is an arrangement where we make one virtual network as hub and rest all other virtual network as spoke. So here in this diagram, we have one hub VNet, which is going to act as a centralized virtual network for rest of the other virtual networks, which is spoke 1 VNet and spoke 2 VNet. As you can see, we did the network peering between hub and spoke 1. So here we have hub and spoke 1 are connected with VNet peering. And we have another VNet peering which has happened between hub VNet and spoke 2 VNet. We know the nature of VNet peering is non-transitive. So VM2 and VM3 are not able to communicate with each other because there is no direct peering between spoke 1 VNet and spoke 2 VNet. So what's the solution here? So here comes the virtual network gateway in our rescue. So you can see here we have deployed virtual network gateway in our hub VNet. We are going to use this virtual network gateway as a transitive networking option. So virtual network gateway is going to help us to communicate between spoke 1 VNet and spoke 2 VNet without any direct VNet peering. So here we are going to see in the lab like how we can use the virtual network gateway to enable or to configure hub and spoke topology. We are also going to use route table in this diagram. So route tables are basically for telling the subnet 1 of spoke 1 VNet to send all the traffic to the virtual network gateway, and the same here for the route table 2 is going to tell the subnet 1 of spoke 2 VNet to send all the traffic to virtual network gateway. So how all this works? Let's go to portal and see by ourselves. So we are in our Azure portal. Now let's validate the architecture we have in our diagram. Let me open the diagram also in parallel. Okay, here is our diagram and here is our Azure portal. So let's first validate the architecture which we have here in the diagram. So in the diagram, we have hub VNet, spoke 1 VNet and spoke 2 VNet. So let's go to virtual network. And here we can see we have one hub VNet, spoke 1 VNet and spoke 2 VNet. If I go to this hub VNet and if I go to subnets, I can see I have one gateway subnet and one subnet 1. In this subnet 1, I have virtual machine 1. Also verified from the virtual machine level. If I look into the virtual machine, I have VM1 hosted in hub VNet under subnet 1. VM2 is a part of spoke 1 VNet hosted in subnet 1 and VM3 is a part of spoke 2 VNet. Now let's go and check the route tables. So we have spoke 1 route table and spoke 2 route table. If I click on this spoke 1 route table and if I click on subnets, so you can see here it is connected to spoke 1 VNet and subnet 1. Similarly, if I go to another route table and it is also connected to, this is the second route table, spoke 2 VNet and subnet 1. So this is our architecture looks like. Now the next task which we need to do is to enable the peering with the help of gateway subnet. So let's go and see how we can do that. So first thing you can see here, we need to set up a VNet peering between hub and spoke 1. So let's do that. Let's go to hub VNet. And here choose the peerings and click on add. Now, first thing I need to provide a name. So this is hub to spoke 1 VNet. And here I'm just going to choose spoke 1 VNet. Now I have better options to read here. So hub to spoke VNet, spoke 1 VNet. So allow hub VNet to access spoke 1 VNet. Yes. Allow hub VNet to receive forwarded traffic from spoke 1 VNet. Yes, we want like this option. Now, if you remember, we talked about in the virtual network peering section, like these are the two options which we are going to discuss later. So this is the time where we are going to talk about these two. So read out this. allow gateway in HubNet to forward traffic to spoke 1 VNet, which means what I'm saying here, allow gateway in Hub VNet. So we have this gateway. So we are talking about allow gateway in Hub VNet to forward traffic to spoke 1 VNet, which means if I enable this, then I'm saying that this gateway should be allowed to send traffic to the spoke 1 VNet. So we need this. Now coming back to this, and the last option, we do not need to use this. Then we need to configure the peering from spoke 1 to hub. Okay, here again, look at the options. Allow spoke 1 VNet to access hub VNet. Yes. Allow spoke 1 VNet to receive forwarded traffic from hub VNet. Of course, we would like this option as well. Now again, these two options. So allow gateway in spoke 1 VNet to forward traffic to hub VNet. So we cannot select this option. Why? Because we do not have any gateway here. We do not have the gateway in spoke 1 VNet. We only have the gateway in hub VNet. So that is why this option is not applicable here. But then there is another option, which is enable spoke 1 VNet to use hub VNet remote gateway, which means I'm saying spoke 1 VNet should be allowed to use this gateway, hub VNet's remote gateway. So this option I need to hit on check and then hit on. So this will basically configure the VNet peering between hub VNet and spoke 1 VNet. Also, in this peering, we have seen spoke 1 VNet is going to use the virtual network to forward the traffic, or virtual network gateway is also going to send the traffic to spoke 1 VNet. So let's maximize it and refresh it. So we have the connectivity between hub and spoke 1 VNet. Let's go and do the connectivity between hub to spoke 2 VNet. So we need to keep the same options. Allow hub. Let's check the spoke 2 VNet here. And now allow hub VNet to receive message from spoke 2. Yes. Allow gateway in hub VNet to forward traffic to spoke 2 VNet. Yes, because the gateway is in hub VNet. Then again put the name spoke 2 VNet to hub and choose the option allow gateway in spoke 2 VNet to forward traffic to hub VNet. We cannot use this because there is no gateway in spoke 2 VNet here as well. So we need to use the same option, enable spoke 2 VNet to use hub VNet's remote gateway, which means I'm telling spoke 2 VNet should be allowed and enabled to use this gateway or the virtual network gateway to forward the traffic. So hit on add. So now if I go to virtual network, here, and if I go to peerings, so I have VNet peering between hub 1 to spoke 1 VNet and hub to spoke 2 VNet. So this VNet peering is added, and now VM1 can communicate to VM2 and VM1 can communicate to VM3. So let's go and log into these VMs and validate it first. So I am logged into one VM. Let's see what host name. Okay, so that's the VM1. And if I look into the virtual machines here, then VM1 should be able to communicate to VM2. So the VM2 IP address is 10.1.0.4. Let's go and check. Ping 10.1.0.4 and we are able to communicate. Let's go and VM3 10.0.2.4. So let's check if VM1 is able to communicate to VM3 or not. So here also the communication is happening. If I minimize this, so VM1 is able to communicate to VM2 and VM1 is able to communicate to VM3. Now let's validate if VM2 is able to communicate to VM3 or not. So we are in VM2. And now we need to check if VM2 is able to communicate VM3 or not. So copy this. Here. And now you can see no response. So request timeout. So VM2 is not able to communicate to VM3. And this is also as per our diagram because there is no direct VNet peering between VNet1 as spoke 1 VNet and spoke 2 VNet. So now let's use this virtual network gateway and which we have already configured in the VNet peering. So now what is left? The left portion is route table. We need to tell the subnet 1 of the spoke 1 VNet, you need to contact or you need to send your traffic to gateway V. And also we need to do the same thing for spoke 2 VNet. So let's go to route table and configure them to send the traffic to gateway subnet. Come here, go to home, go to route tables. So we have a spoke 1 route table. So this route table is associated with spoke 1 VNet. We need to add a route here. Click on add. So route name could be connection to spoke 2 VNet because we are in spoke 1 VNet, so we can say it is connection to spoke 2 VNet. Destination type should be IP address, and here it is asking the destination IP address range or the CIDR range, which means we need to provide the IP address range of VNet 2. So let's go here and check what is the IP address range for spoke 2 VNet, and the address space is this. So choose this option, come to here and put it here. Now the next hop type, which means we need to tell the traffic should go to which service. So you can see here virtual network gateway is already listed here. There are some other options as well which we will learn in the later sessions, but as of now let's choose the virtual network gateway. We'll choose the virtual network gateway and hit on add. So in this routing, what we did, we tell spoke 1 VNet like send all your traffic to virtual network gateway. The similar set of routing, we need to do it in the another route table. So here we can mention connection to spoke 1 VNet, select the range, and if I copy the spoke 1 VNet address space, which is this, and again next hop type should be virtual network gateway, and hit on add. So this routing is also completed. Let's go back to the image again and see. So as per our configuration, we did all configurations here. We created VNet peering, we used virtual network gateway, and we also created route tables. So now let's go to VM2 or VM3 and see if they are able to communicate with each other or not. So this is VM1. So this is VM2, hopefully. Yes, this is VM2. And this is the IP address of VM3. So let's try to communicate. And you can see VM2 is able to communicate VM3. Let's validate the same from the VM3. We are in VM3, ping 10.1.0.4, which is the IP address of VM2. We can verify it from here as well. So VM2 10.1.0.4. So from my VM3, I'm also able to communicate to VM2. So this is how the hub and spoke topology works. So let me go back to the PPT here. So till now, what we have seen, we have configured hub and spoke topology with the help of virtual network gateway. Now let's go to our slide and see what's next. So here we have configured hub and spoke topology models. Now, if I deploy hub and spoke topology model in a production environment, then it looks like this. Because we know virtual network gateway is not only used for the internal networking traffic, it is also used for on-prem infrastructure as well. So here you can see we have hub VNet, we have a spoke 1 and a spoke 2, which are communicating through virtual network gateway with each other. And virtual network gateway is also able to communicate with the on-premises infrastructure over the internet by using the site-to-site VPN or express route VPN. So that's all about hub and spoke topology. So just to recap what we learned till now. So we have learned what is virtual network peering. We did the virtual network peering. After that, we have worked on virtual network gateway. We deployed how the virtual network gateway is done. And with the help of virtual network gateway, lastly, we see hub and spoke topology and how to configure it. So that's all about this session. Let's go to the next session where we are going to review some questions related to Az-700 exam preparations and understand them in detail. Here is our first question. So it says, you have an Azure subscription that contains 4 virtual networks named VNet 1, 2, 3, and 4. Now you plan to deploy a hub and spoke topology by using virtual network peering. Good enough. You need to configure VNet 1 as hub network, and the solution must meet the following requirements. It should support transitive routing between spokes and maximize network throughput. So what should you include in the solution? Now understand the question. In this question, it says we have 4 virtual networks, namely VNet 1, 2, and 3, 4. And it says we need to configure VNet 1 as a hub network, which means other VNets are going to act as a spoke network. Also, it says we need to use this transitive routing between the spokes, which means they are not directly network peered. So we have to look at the options, and by looking at the options, we can easily tell like the transitive routing between spokes and hub and spoke topology can only be possible when we have Azure VPN Gateway in place. So let's have a look on the answer. Yes, the correct answer is Azure VPN Gateway. Let's move to the next question. Okay, this is a long question, so understand it. You have the hybrid network shown in the network diagram exhibit. It says on-premises network we have, then on-premises network is connected by using site-to-site VPN and Azure Virtual Network and Virtual Network 2 and Virtual Network 3. So Virtual Network 3 is directly paired with VNet 1 and VNet 2 is also directly paired with VNet 1. So VNet 2 and VNet 3 are not paired here. So understanding the diagram is most important here. Now we also see like this VNet 1 is connected with the site-to-site VPN, which means there must be a virtual network gateway here. So now let's move to the next part of this question and see what are the options. Okay, so the next part of the question says you have peering connection between VNet 1 and VNet 2 with below settings. So we can see here we have peering connection between VNet 1 and VNet 2. So we are going to follow the settings. You can see here the name, traffic to remote virtual network. So we are in the VNet 1. So it says traffic to remote virtual network, which means traffic to VNet 2 is allowed. Yes, it should be allowed. Traffic forwarded from remote virtual network. Yes, from VNet 2 to VNet 1 is allowed. Now virtual network gateway or route server is actually set to none. Fine. Then coming to the second part of the peering, which says VNet 1 and VNet 2. And it says traffic to remote virtual network should be allowed. Okay, we understand the settings. Now next, again go back to here, and VNet 3 and VNet 1 is also paired. So look at the settings of this pairing. In this pairing, we can see VNet 1 and VNet 3, traffic to remote virtual network. So in this case, remote virtual network will be our VNet 3. So VNet 1 and VNet 3 traffic is allowed, which is good. Traffic forwarded from remote virtual network, it should be allowed. And again, the use of virtual network gateway is set to none. Fine. Then the next part says these are the settings inside the remote virtual network. So it says traffic to remote virtual network, which means VNet from VNet 3 to VNet 1 is actually allowed. Yes. Traffic to remote virtual network is also allowed, which is fine. Now traffic forwarded from remote virtual network, yes, it is allowed. Virtual network gateway or route server is again set to none. So we have to focus here and understand that virtual network gateway is always set to none in both the conditions. Let's move to the next part of the question and see. Now it says for each of the following statements, we need to choose yes or no. So what's the first statement? It says the resources in VNet 2 can communicate with resources in VNet 1. So if I go back to my diagram, it says resources inside the VNet 2 can communicate VNet 1. Resources to VNet 2 can communicate with, yes, they can communicate because they are directly paired. So it should be yes. Now the second statement, resources in VNet 2 can communicate with the resources in VNet 3. So resources in VNet 2 can communicate with resources in VNet 3? No. First thing, they are not directly paired. Second, we have also not seen the use of virtual network gateway. So they are also not using the virtual network gateway to communicate. So the answer should be no. Now the resources in VNet 2 can communicate with the resources in on-premise network. So VNet 2 can communicate with the resources in on-premise network. So VNet 1 is connected with the on-premise and VNet 2 is directly connected with the VNet 1. So VNet 2 should be allowed to connect with the VNet 1, but look at the settings here. It says for the VNet 2, it's not using the virtual network gateway. So if you can see here the virtual network gateway, VNet 1 and VNet 2 pairing, virtual network gateway is not allowed. So if you are not using the virtual network gateway in the peering, then your paired network is not going to able to communicate with the on-premise network. So it should be no here. Let's look at the answers. Yes. So the resources in VNet 2, of course, can communicate with VNet 1 because they are directly paired, and the VNet 2 is not going to communicate with VNet 3, and VNet 2 is also not going to communicate with the on-premise network. Why? Because none of the peering settings are using virtual network gateway. That's all. Let's move to the next question. We are in third question. So you have an Azure environment shown in exhibit. Okay, let's understand the diagram. So we have VNet 1, VNet 2, VNet 3, VNet 4, and VNet 5. Good. So VNet 2 is connected with VNet 1 by direct peering, and VNet 5 is connected with VM 4 by direct peering. Good. And now VM 1 is using the gateway server to communicate with VM 3, and VM 3 is also using the gateway server to communicate with VM 4. And this is the gateway server or our virtual network gateway. Now the second part says you have virtual network peering between VNet 1 and VNet 2. We can see that VNet 1 and VNet 2, and between VNet 4 and VNet 5, VM 4 and VNet 5. Good enough. Now the virtual network peering is configured as shown below in the table. Virtual network, VNet 1, VNet 2, VNet 4 and VNet 5. So VNet 1 says traffic to remote virtual network is allowed, which means VNet 1, for the VNet 1 traffic remote virtual network should be VM2, and it says, and VM3 as well. So it says allowed. So VM1 can send traffic to VM2 and VM3. VNet 2, again traffic to remote virtual network is allowed, which means VM2 can also send the data to VM1. VNet 4 is allowed, so it means VNet 4 can also send the data to VNet 3 and VNet 5. VNet 5 is blocked. Okay, that's interesting. So VNet 5 is not able to send data to VNet 4 because it is blocked. Next option, use remote gateway. So VNet 1 says none. So VNet 1, here we have VNet 1 and the gateway, use of remote gateway is set to none. So for VM1, the remote gateway should be either in VM2 or in VM3. So we don't have the VM2 gateway, virtual network gateway here. So it is set to none. For VNet 2, the use of remote gateway is enabled, which means for VM2, the remote gateway will be gateway 1. So it is allowed. For VNet 4, use of remote gateway is none. So VNet 4 can also cannot use the gateway, which is fine. And for VNet 5, it is enabled, which means VNet 5 can use the gateway, virtual network gateway in VNet 4. Again, now the last option, VNet 1 allow gateway transit, which means enable. So VNet 1 allow gateway transit says VM1 or whatever the virtual network gateway we have in VM1, it is going to allow the traffic. So it is set to enable. VNet 2 allow gateway transit is set to none because we do not have a gateway here. VNet 4 again allow the gateway transit because VNet 4 also has a gateway, so it is set to allow, which means it can send the traffic. And VNet 5, it is set to none because again, we do not have any gateway here in VNet 5. Now let's look at the question. So for each value and statement, select yes if it is true. So see, VM1 and VM4 can communicate. Let's see, VM1 and VM4 can communicate. Yes, they can communicate because VM1 has the gateway and it is allowed. So you can see here VNet 1 has the traffic to remote virtual network is allowed and allow the gateway transit is also allowed. So, and the same setting for VNet 4. So VNet 1 and VNet 4 can communicate with each other. So the answer to this question should be yes. Now VM2 and VM4 can communicate. So VM2 and VM4. So VM2 is directly paired with the VNet 1 and VNet 1 is basically allowing the gateway transit. So it should be connected to the VM4. Okay. And VM1 and VM5 can communicate. So VM1 we have here and VM5 we have here. So can they communicate? No, they cannot communicate because if you look at this setting, traffic to remote virtual network is blocked for the VNet 5. So VNet 5 is basically not sending any traffic to outside. So that is why it should be no. So let's go and see the answer. You can see VM1 and VM4 and VM2 and VM4 absolutely they can communicate, but VM1 and VM5 cannot communicate. I hope I explained this question and it will be helpful to you. So let's move to the next section. Here we are in our next question. You have Azure Virtual Network named Hub1 and Spoke1. Good enough. Hub1 connects to an on-premise network by using site-to-site VPN connection. Okay. Now you have to implement peering between Hub and Spoke1. Okay. And you need to ensure that virtual machine connected to Spoke1 can connect to the on-premise network through Hub1. So how should you complete the PowerShell script? Okay, they have given a PowerShell script. So let's not worry about the PowerShell script. Just try to read and I'm sure we'll be able to understand that. Okay, so the concept here is we have two virtual network, Hub1 and Spoke1. Hub1 is going to interact with the on-premises. and we need to do the network peering between hub 1 and spoke 1 so that spoke 1 can also connect with the on-premises. And we know when we are going to deploy the hub 1, we also need to deploy a virtual network gateway because we are using the hub 1 to connect on-premises network. So virtual network gateway is absolutely going to be a part of this hub 1. So how we can do the networking between hub 1 and spoke 1 so that spoke 1 can also communicate the on-premises. Let's look at the options here. You can see here it says $hub get AZ virtual network and resource group and then hub 1. So it's basically nothing. It's capturing the hub virtual network name in hub variable and spoke virtual network in spoke. And now this is the command add AZ virtual network peering. So it's basically going to do the same thing which we achieved or which we did by using the Azure portal. So here, if you read add AZ virtual network peering -name hub to spoke 1, and virtual network should be first hub, and then remote virtual network should be spoke. So remote virtual network absolutely in hub 1 and hub 2. So when we are doing the peering from hub 1 to spoke 1, the remote virtual network is going to be spoke 1. Now we have to enter the value. So we have 3 values: allowed forwarded traffics, allow gateway transit, and use remote gateways. So if we are doing the peering at the hub 1 end, so we have to ensure that hub 1 should be allowing the gateway transit because this is the setting which is going to enable the virtual network gateway to send or receive the traffic. So our answer should be allow gateway transit here. Now coming to another virtual network peering, which is between spoke 1 to hub 1. So now here spoke 1 is the VNet and hub 1 is also VNet, and we need to do the peering. So it says remote virtual network is actually hub 1 in this case because we are doing this peering, and hub 1, what should be the next value? So it should be allow forwarded traffic or use remote gateways. Yes, it should be use remote gateways because spoke 1 should use remote gateway, which is hub 1's gateway, to do the transition or to do the communication. So let's see the answer. Yes, you can see allow gateway transit and use remote gateways. So I hope this explanation helps you to understand the question. Question number 5. Here we are planning the IP addressing for the subnets in Azure Virtual Network. So which type of resource requires IP address in the subnets? Okay, that I can say it's a pretty easy one. So here what they are planning to deploy Azure Virtual Network and in the subnets. And they're saying like which resource going to require the IP address. So storage account, no. Internal load balancer, no. And service endpoint, no. Virtual network peering, yes. So virtual network peering is the component where we are going to need the IP address. So that should be our answer. Okay, here we are in our next question, which is we have Azure Virtual Network named Hub 1, Spoke 1, and Spoke 2. Okay, Hub 1 connects to an on-premises network by using site-to-site VPN connection, which is fine. Spoke 1 and Spoke 2 needs to connect via virtual network gateway. Okay, in which virtual network gateway is required to deploy and which option is mandatory to create gateway. Okay, so in portal, we have 3 virtual networks, Hub 1, Spoke 1, and Spoke 2. So Hub 1 is going to use virtual network gateway to communicate on premises. And Spoke 1 and Spoke 2 going to be connected with Hub 1. So it says virtual network where we are in which virtual network we should deploy virtual network gateway. So ideally it should be Hub 1. And it says which option is mandatory to create gateway. So if you look at the options, Spoke 1 and private subnet, no. Hub 1 and firewall subnet, no. Spoke 2 and gateway subnet, no. Hub 1 and gateway subnet, yes. Hub 1 is the network or the virtual network where we are going to deploy our virtual network, virtual network gateway. And yes, gateway subnet is a mandatory part. Whenever we are going to deploy a virtual network gateway, we need to deploy a gateway subnet. So I hope this should be the answer. Yes, this is the answer. So this is all about the questions we have reviewed. This brings us at the completion of this session. Thank you for attending today's class at 591 Lab. We hope you found the material informative and helpful. Remember, practice is critical to mastering any new skill. So review the course content and keep practicing with 591 Lab help and support. If you have any question or concerns, please do not hesitate to contact us. We appreciate your participation and look forward to seeing you in our future classes. Before signing off, a humble request to like the video, subscribe the channel, and hit the notification bell. Thank you and have a great time ahead.